Welcome to Edureka. This is Anuj. Today, what we will also try to do is we will try to see that how we integrate the GUI and how do we create the entire application in the Truffle framework or in a Truffle environment. Currently, we are seeing only backend part in Remix, how we are able to create our contract, how we are able to test it using the environment in the Remix and also using the Ganache and MetaMask. All that we have already seen. Now, today we will try to also see that how we can build it in the Truffle, how we can integrate the GUI and how the overall application looks like. So let's quickly run through some of the examples that are remaining. This is the example of a escrow contract. So we have a buyer and we have a seller. We have 4 states that we have defined. Uninitiated is the initial state. Awaiting payment is when seller is awaiting payment from the buyer. Awaiting delivery is when the buyer is awaiting the delivery from the seller. And complete is when the transaction is complete. The key thing about escrow contract is that both buyers and seller need to put the stake on the network, because we are working on a centralized distributed network where the entities, for example, we are working on a system where entities do not know each other. So there is no identity that has been established. They are random people on internet who are doing the transaction. So in order to establish some kind of a authenticity, what we are doing is we are taking the equivalent amount of money from both buyer and seller as a deposit. And then when the transaction is done, then we are returning that money back to them. So this is the structure function. We are initializing buyer with the buyer address. We are initializing seller with the seller address, and we are determining the price of the item that we are going to buy. So we will need to give these 3 parameters in the constructor itself when we run this program. And we will need to remember which address we have designated as a buyer, which address we have designated as a seller, and how much price we are giving. Then the first function is, and this is a payable function. Payable function means there is some kind of a value that we will need to give when we run this particular function. So there will be some ether or way that will be associated with this function, and they will be spent during this. So it will check that price is matching with the original price that we decided during the constructor or not. First of all, it will check that if it is from a buyer, then it will set the flag for the buyer as true. If it is from a seller, then it will set the flag from seller as true. If both buyer and seller have run this function and basically deposited the amount of the price to the network, then the state will be changed to awaiting payment. So we are changing the state from uninitialized, which is 0, to awaiting payment when both buyer and seller have deposited the money to the network. Then there is a second function. Second function, what we are doing is buyer is actually doing the payment. Again, where he is doing the payment? He is doing the payment to the network only. So what buyer is doing, we will check that, okay, if the message sender is buyer and if the message value is that of a price, then change the current state to awaiting delivery. Awaiting delivery means that, buyer has given the money. Now he is waiting for the delivery. Now assume that, the seller has sent the delivery, and after that the function confirm delivery is called. Then what we will do after that is that it will again check, okay, if the message sender is a buyer, because the buyer will confirm that the delivery has happened. Buyer can only tell that he has received the delivery. So buyer will run this function. So therefore we are checking if the message sender is a buyer, then transfer 2 times the price to the seller. One, the amount that he deposited to the network, and second, the price of the item itself. The seller is getting 2 times the price of the item, and buyer is getting 1 time the price which he initially deposit as a escrow contract, and then the state will be changed to complete. So basically both are depositing money, and then after the payment is confirming, seller is sending the item, and then after the delivery is confirming, then we are returning the money back to buyer as well as seller. Seller will get twice the money and the buyer will get 1 time. Let's try to run this quickly. Okay, this is compiled. Now we have got these accounts, and these are all my Java VM, JavaScript VM accounts. So what I am going to do is, now before I can deploy, I need to give buyer address, seller address, and price, because that's what I defined in my constructor. Before I can deploy, I need to give the address of buyer, seller, and a price. Now let's say my first address is my buyer, 0x694. This is my buyer. So I will copy this here and I'll put it here. This is my buyer. Now let's say my second address 0x154. This is my seller. So I copy it here and I put it as seller. Now let's say the price of the item is 10,000 Wei. So let's say this is the price of the item that we are trying to work with. So what I will do is I will change back this original address and I will deploy this contract. I have designated the buyer, I have designated the seller, I have given the price. Now I will deploy this contract. Now this contract is successfully deployed with the buyer address, seller address, and also the price. The price here is shown in hexadecimal. Now let's see this contract. So these are the functions that are available. The functions in the red are the ones which are payable function. The functions in the red ones are the ones which are payable function, where some kind of a money exchange is happening. And the function in the orange is a setter function. Rest of these are your public variables. So if you see initially buyer in is false, seller it is in false. Seller we have the address that we have given for the seller. Buyer we have the address that we have given for the buyer. Current state is uninitiated because we have not done any transaction as yet. So current state is 0. Price we have given as 10,000 ways. So that is the price. This is the initial state. Now what we will need to do is we will need to do initiate contract. So we will need to run this function 2 times, one with buyer and second time with the seller, because both will deposit the money and then only the current state will change to awaiting payment. So now currently buyer is selected here. So I will the value 10,000 Wei. So for example, if I don't put 10,000, if I only put 100 ways, and then if I try to run say initiate contract, so I will get error because this particular condition will fail. Require message value is equal to price will fail, then I will get error and therefore it will not run. So I will need to give 10,000 here and then I will say initiate contract. So now it has run for buyer. So this condition will be set to true. So buyer in will be true. Seller in will still be false because seller has not deposited the money as yet. Buyer has deposited 10,000 ways in order to initiate this contract. Now the seller will also need to do this. So we will need to select seller's address here. Again, we will need to give 10,000 ways and again we will do initiate contract. This has run successfully. So now if you will see seller in will also be set to true. Price is still and current state will change to 1, which means that we are awaiting payment now. Now initiate contract is done. Both buyer and seller have deposited 10,000 ways each to the network. Now we are at confirm payment. Confirm payment means that buyer is again depositing the price of the item to the network. Now we will need to select the buyer here. So for example, if we don't select the buyer, if we select the seller and we say 10,000 ways here and we run confirm payment, it is giving error because only buyer can run this function. There is a require statement which says that only buyer can run this function and the price should be equal to the message dot value, which means 10,000 ways, and then only the state will change to awaiting delivery. So what you can notice here is that by using the smart contract functions, we are defining the conditions that is making sure that our contract is running as per the norms that we have decided. And these norms are generally manual in nature when you do these kind of transactions. So let's select buyer. Let's put the value as 10,000 ways and let's do confirm payment. So now confirm payment is done. So the current state will change to 2. Now the buyer has given the payment of the item. What you can also see that the buyer has given more money than seller. You can compare these two values. Then the last function that we will need to run is, and only buyer can run this function, is confirm delivery. Confirm delivery means that buyer has got the money. Now the seller will get 2 times the value and the buyer will get the deposit money that he initially deposited. Now the item is delivered. Now we have already selected buyer. There is no money involved here because it is not a payable function. We are not depositing any money to the network. What we are doing is we are pressing confirm delivery. So now confirm delivery is done, which means they have got their money back. Some amount is added to both of them. And what has happened is that the state is changed to 3. This is another contract. And in this contract, we have defined a wallet. So assume that among all these accounts, there is an account that is a wallet account and that account is giving the tokens to various other addresses. One of them is a wallet entity and that account is distributing tokens For example, if this is the one who is a wallet application and is one of the node, and he is giving the tokens for a certain price. For example, he is giving tokens for 5 ether each. This is basically that kind of an example where we are creating a wallet which is capable of giving the tokens to any address that pays him money. So additional concept is, one is this, I think, event basically means that if you want to notify the third parties about what you have done in your contract, then you can use emit event, and you can give parameters. Like for example, here we have defined event with two parameters. One is who is the buyer and what amount he has paid to buy these tokens. So we are emitting this as an event. What we are also using is a log function. There are three log functions: log 1, log 2, log 3. So if you want to save your transactions in a local format or in a local file, then you can use the log function, where it will save the text that you are passing as a parameter in the log function. If you use log 1, that means you can pass two parameters. If you use log 2, that means you can pass three parameters. If you use log 4, that means you can pass 5 parameters. So this, and then we have also defined an external table function which can be called from outside of the contract only, which cannot be called from inside the contract. So this will not be visible when we compile it. So these are some of the additional concepts that we are doing. So what this particular contract is doing is, we are defining a balance, and each balance is associated with a particular address. So assume that there is a token and you can buy one token. So each of these address will have certain amount of tokens. Initial value of those tokens will be 0. Now they can purchase the tokens from a wallet address. So the wallet address is having all the tokens with him. Now this particular function, what it is doing, the constructor is only initializing the wallet. So we can define that which address is a wallet function. And this function buy token, what it is doing is, it is increasing the balance, which is this particular mapping, which means this address is increased by 1. So it will get one token, and it is transferring the value, whatever we are mentioning, as a ether or as a value of this token. And it will also emit a event, and it will also add the log. This is the program. Let's try to compile and run it. Let's use the earlier version. So this is the contract. Now the constructor will expect the address of the wallet. So I will need to designate one address from this as a wallet address. So let's say, for example, I pick this address. So this member of my network is a wallet, and I say transact. So if I see the wallet address now, wallet will show 0xDB8. So this is my wallet address. Now, for example, if this person wants to execute buy token, then he will need to pay the price of that token. Let's say the price of the token is 5 ether. Let's say that you are valuating your currency at 5 ether. We give 5 ether here, and although we have not any condition, we can also put a require condition here that it should be equal to 5. Message dot value should be equal to 5, or any value that you want to associate. We have not put any condition here. So let's see what happens. So let's execute this particular function buy token. So it's a payable function. We have already mentioned 5 ether as a value. So let's execute buy token. It is executed successfully. So few things to be noticed here. One, you will see the 5 ethers are deducted from this, and 5 ethers are added to this particular address. This wallet application has gained 5 ethers. This address who has purchased this token has lost 5 ether. That is number one. Number two is, if I see the token balance of this particular address who has actually purchased this, if I give the address as this, then I can see token balance as 1. If I give any other address, then it will be 0, because what we are doing is, we are increasing the balance by 1 each and every time we are executing this function, and we are increasing the balance of the message.sender. Message.sender is the address which is basically present here. So wallet address will always remain same. The wallet is capable of distributing the tokens to various addresses. Now let's say, for example, if this address wants to buy another token, again he will give the value of 5 ether, and again he will say buy token. Now his ether balance has gone down to 89. This ether balance has gone 109, and if I see the balance of tokens for this particular address will be 2. This is just like creating a simple wallet application and exchanging the tokens with it. Let's see some of the examples of object-oriented programming concept that are used in Solidity. So you must have done, or you must have heard about polymorphism, must have heard about inheritance, you must have heard about tracked functions, you must have heard about interface classes. All these concepts are being used in Solidity as well. In a similar way, they are being used in Java or JavaScript. This example basically gives you the illustration of the function overloading or the polymorphism, where you can have the same function name doing two different things. Then I think we also have an example where we are doing the inheritance of a parent contract into the child contract. So here you have multiple contracts. We are doing the basic inheritance or a public inheritance of a parent contract into the child contract. If you see how many contracts are there, one is this hello function polymorphism. This is one contract. Parent contract, this is another contract. Child contract, this is another. Three contracts in this file. So you can choose to run any contract, and the first contract, what it is doing is it is defining the same function name. However, the first function is getting int 8 as a range, and the second function is getting int 16 as a data range. So if we send value which is greater than 128, then by default this function will be executed, and this will be the return value. And this parent contract function, this is nothing but what we are doing here is we have a setter function, we have a getter function. In the getter function, we are only returning 10 here. We are not returning the value of simple integer. But when we are inheriting this function in a child contract, then again we are implementing a getter function with the same name. We are using the concept of polymorphism here also. But instead of returning the 10, we are returning the value of the integer. So let's see how these contracts run. You can run it from any address. Here you can see there are three contracts: child contract, parent contract, hello function, polymorphism contract. Let's try to run the first contract. This is our first contract. We have just deployed it. So this contract is deployed. Now we have two functions here: get variable data. Both are listed. First one is accepting int 8 and the second one is accepting int 16. And we are just returning the data, whatever is coming. So here we can only give output is 100. Here we can give the bigger values. Output is 4000. If we give out of the range value here, then it will not give you the correct output because it will not accept the data. So these are the same function names doing two different things. Similarly, if we deploy the parent contract, let's see how it works. So this is our parent contract. There are two functions. One is your setter, one is your getter. The getter function is returning a fixed value. The setter function is setting the integer value. So let's say, for example, if I set the value of integer as 59, if I say get integer, it will still return me 10. If I inherit this parent class or a parent contract to the child contract, and if I run the get integer function again, then it should return me the right value. So if I deploy the child contract, I will again see set integer and get integer. I will again see these two functions. So if I set a value of, let's say, for example, 55 here, and if I say get integer, I will get the value 55. So this is inheritance as well as polymorphism. So this function is getting overwritten by this particular. So these are some of the things, basic things that you use in any object-oriented language, and the same way it is used in Solidity as well. Similarly, you can create multiple objects. Although rarely write a program in Solidity or contract where you will need multiple instances of the same object, but the way you define dynamic arrays, similarly you can define dynamic contracts also. So one of the example is, although it is rarely being used, but if you want to define multiple elections on the runtime. So for example, if it can happen that 4 different elections can happen at the same time. So if you are defining a election contract, it will only save the data for one election. So therefore, if you want to dynamically create your contracts based on the number of such contracts executing at the same time, all of them will be maintaining the different data sets. So you can create the dynamic contracts as well during the construction phase and the other classes as well in the public inheritance kind of a situation. So let's see if we have some example. So this is one example where we have a contract D and we have a contract C. This contract D is having a constructor function which is a payable function. So basically, when the contract is getting created, it is getting created with some value. So therefore, it is a payable contract. And then we have a contract. Okay, it is not inheriting contract D, but because it is public, So therefore, we are creating the 4 instances of contract D. And we have defined a public function where, based on the parameter, we can define a new instance of contract D. And we can also define a public function where, we are also sending the payable amount to this D. So for example, if you compile and run it, you will see that there are 2 contracts here. One is your C and another is your D. So if you run the C contract, you will need to give some value here, for example 10 ether, and you will say deploy. There is no public function here, which will be displayed. It is just dating a contract as a payable contract, and that is all it is doing. Now, if I deploy the contract D, so initially I should have deployed contract D. Contract D is expecting a value A here, and it is assigning the same value to the X. So for example, if I give the value as 10, and I also give the value as, say, for example, 15 ethers, because it is a payable function. So if I do transact, then this will be deployed here, and X I can see as 10. Now if I deploy contract C, now contract C will have functions. One is your pub, another is pub2. If I execute pub function, I can give how many instances I want to create. So this is like telling that how many elections are coming up simultaneously. So for example, if I say 5 and if I do transact, it will create 5 instances of this D class or D constructor. If along with number of instances, I can also say that what amount of ways do I want to initialize these classes with, then I can say transact, and it will create 5 instances of contract D with this amount already tagged to all these accounts. So this is how you typically create dynamically new contracts. These are rarely used in smart contracts, but there can be situations where you will need to create these dynamically. So that basically covers all the concepts: arrays, dynamic as well as fixed arrays. We have also used length function. We have also created fixed and dynamic both arrays. But what we have also seen is that the mappings are much more preferred than arrays. Arrays are not very often used. Mappings are used. The difference between pure and view is that pure even cannot read the state variables, and the view and constant are same. They can read, but they cannot modify any information in the state variable. Memory storage, seen that everything which comes as a parameter is memory. Everything that we define as a state variable is storage. The return parameters are also memory variables by default. We can define dynamic arrays like we define these dynamic classes. We have seen mapping, we have seen structures. These are dynamic arrays where you are defining 8-byte array. This is a dynamic string that we are defining based on the size as a parameter. Now, abstract contract, any contract where one or more functions lack an implementation is called the abstract contract. So for example, if we define this contract fill-in, and if we leave this function without any code or without implementation in the base class, then this contract is known as the abstract contract. You will need to implement this function in any of the contract which is implementing or which is inheriting this class. So for example, this contract cat is inheriting the contract fill-in, and it is implementing this particular function, utterance, and it is returning the value meow. So therefore, although this function was not implemented in the base class, this is getting implemented in the child class. Such classes are called as abstract. So next is your interface. Interfaces are similar to abstract contract, but they cannot have any function implemented. Contracts can inherit interfaces just like they inherit other contracts. The difference between interface and abstract contract is that interfaces are defined with the keyword interface. So instead of writing the word contract, you will write the word interface, which will clearly mean that all the functions which are part of this interface will not be defined in this contract. Rather, they will be defined in the child contracts. So those are the interfaces. You can easily write any source code or any easy examples for interfaces and abstract classes. We created a math library, plus minus, divide, multiply, and we have already used that library. This is also an example of creating a setter and getter function using the library. You can import any library or any source file or any SOL file using the import keyword. In the earlier versions of Solidity, you were not supposed to write emit before the event. In version 4.0, in the latest version, you also need to write emit. So the examples that we have done, so in voting contract, we have used voted event, which we have called directly here because this is the older version of compiler 4.20 that we are using. Here, if you will see in a new version of compiler, you will need to add emit keyword before event. So you will write emit and then the name of the event. The definition of event will still remain the same. You can define an event just like you define the structure, then you can emit it from any function that you want. So this is the example of event. Okay, you can call it from anywhere. Logs, as I mentioned, you have log 0, log 1, log 2, log 3, log 4. So depending on the number of parameters that you want to pass, you can define a log function. In this example, we defined log 1 where we passed parameters. Both of them were string. You can also convert a value into the string by casting it, bytes 32. If it is log 1, then you will need to pass 2 parameters. If it is log 2, then you will need to pass 3 parameters. And these logs will be visible here. So use the compiler version greater than 5.10. Use any version which is greater than 5.10 or equal to 5.10. Then you will not get that error. Now, for example, you can use require this is equal to this value. So it will give you the error in case this is not. Similarly, you can use assert also. Assert this balance is equal to this. Now, these are some of the common pitfalls or the errors that we encounter, or these are some of the things that you should not be doing when you're writing the smart contract. One thing that you need to remember is that any variable that you define in a contract above the function is basically your state variable and is visible publicly. Publicly means all the nodes can access that information. So just be careful, what variable you are defining where, because you don't want to share private information or a memory variable information, define it that way. Don't define it as a public variable because it will be stored in the state database of every node and each and every node can see this information. Use the check effect iterations pattern to avoid reentrancy. Always put conditions. For recursion, we can always write a loop. If you have done the programming, you might already be knowing that recursion is just, or reentrancy is just a replacement of a loop. So it's better to write a loop with a ending condition rather than writing a recursive call. Gas limit and loops. If you are writing a longer loop or infinite loop, your gas limit will get exhausted and you will not be able to execute your contract successfully. Tx.origin is basically same as message.sender. The only difference is that whenever you select a different address, the message.sender is changed, but tx.origin always remains as the one where you initially deployed the contract. Tx.origin will only be the address where you deployed the contract, while message.sender will be the address which is the currently selected address in the message.sender. But if you write tx.origin here, that will only be the address where this contract is deployed initially. So if this was the address where we deployed this contract, tx.origin will always return you this value. For example, if you define or if you want to define some kind of an admin where this initial contract is deployed upon and you want to keep that person as an admin of the entire addresses, then tx.origin can always tell you that where this contract was deployed and you can put the conditions accordingly. So for example, he has put the condition that do the transfer only when the tx.origin is the owner, otherwise do not do. The recommendation is restrict the amount of ether that you are spending, keep it small and modular. Use the check effect iterations pattern rather than using the recursive functions, and include a fail-safe mode. So always use the error conditions, log and events whenever possible. So these are some of the general aspects of any programming language or any program that you write. Some of the things that you always need to keep in mind, like make your contracts small and user friendly, filter out unrelated functionality in other contracts or libraries. So if there is a repetitive functionality, better to write a library. Pick the amount of local variables and the length of the functions. Always document your functions. So always write the comments. And in Truffle, there are libraries which are available that automatically creates your documentation as well. So once you create your functions, it automatically creates your documentation. What are the input parameters? What are the out parameters? What is the function doing, etc., etc. Now you should always use check effect interactions patterns. So whatever parameters are coming, you should always check whether they are valid parameters or not. Like for example, we used require at multiple places. Similarly, you should see that the transaction is coming from a valid entity or not, and then only you should allow the transaction to complete. Contract API, this is a binary application, binary interface, which along with the bytecode goes to your Ethereum virtual machine, and that can be deployed at any node, be it Windows, Mac, or this. Now the next part is how do you set up your environment Ubuntu or Linux. So what you will need to do is the VM that you have installed from Edureka, you will need to install these software on that VM. I think what we can do is I can quickly tell you that what is the difference between Ethereum and Quorum. It was realized while the Ethereum solution was getting popular that there is no notion of privacy, or there is no concept of keeping the data private to certain nodes, which is a prime requirement in any kind of a business scenario. And therefore, a new hard fork was created from Go Ethereum or Geth client, which was known as Quorum. Quorum is again a consortium based blockchain. It is basically a group of companies that own it. And the key difference between Quorum and Ethereum is the first difference is that Quorum does not use proof of work. It neither uses proof of stake. It uses the simple voting mechanism for the consensus. So the way consensus is achieved in Quorum is through the voting of nodes. So the nodes verify the transaction is correct or not, and based on their votes, the transaction is accepted or rejected. So there is no proof of stake. Consensus is pretty much simpler. So that is the first difference between Ethereum and Quorum. It is written and compiled in Solidity only, in the same way that you compile your Ethereum contracts. Only difference is that the Solidity is extended to basically define the data types for certain nodes. So you can have the private data sharing. When you define a variable here, it gets shared with all the addresses which are there. If you are defining a quorum based contract, and you can do it in Remix itself, you can restrict the data sharing to certain nodes. You can mention that what all addresses will have access to this data. So that is another key difference between Quorum and Ethereum, that you can have a restrictive private data sharing, and in Ethereum all the data is shared with all the nodes. So that is number two. Let me transfer the control to my Linux machine. I think first thing that you will need to do is you will need to install Git. If you have a Linux machine, create a new folder. Say, yeah, my machine, because I keep on using these softwares frequently, they are already installed. But you should try to get them installed in your machine. So first of all, you will need to install Git. Second, you will need to install Node.js from this link. And since we will be installing it on Linux, so therefore you will need to download the Linux package and you will need to install it, and the commands are already given. So you will need to run these three commands. First of all, you will need to download the setup of Node.js, and you will need to install Node.js, and then you will need to install the subsequent utilities that come along with Node. So basically three things that you need to download. One is Git, another is Node.js, and third is NPM. So these are the mandate things for setting up the environment. And then you will need to download the Truffle framework. And then you should have Ganache, and you should have what you call MetaMask as a Chrome extension. That basically completes your development environment. Let me try to showcase some of the simpler things, like for example, MetaMask Chrome extension already know. Installed Ubuntu via Windows 10 USL is so MetaMask you can install from Google Chrome extension. You just need to say add extension and it will be installed. Here it is saying remove because it is already installed in my machine. You can just say add and it will be installed in your Chrome browser. Should also have Chrome browser. And I think one thing which I missed is you also need to install one IDE. Like I generally use Visual Studio Code. I generally use this, and this is the preferred ID both for Hyperledger as well as Ethereum. I think this should be good enough. Need to install all these things. MetaMask I have shown you. Visual Studio you can again simply install it. Well, you can just download and install it on your Linux machine that you can install .deb or Ubuntu. then just need to install it. So this is the Linux console that you are seeing. Need to install them on Linux. So here you can install this. Then need to go to Truffle. From Truffle framework, you need to install Ganache. Ganache, just download and install it on your Linux. It will show you the download option for Linux. These are some of the visual softwares that you need to install. And then some of the things you need to install command line, like your npm and your this thing. Get the link on your chat. You need to install Node.js, you need to install npm, follow any of these processes. Then you will also need to install the Truffle framework. And for installing the Truffle framework, you can just this command. For installing the Truffle framework, be able to install the Truffle framework only after you have installed the rest of the dependencies. Just need to give npm install -g Truffle. Or maybe I can run this command although it is installed on my machine. Npm install -g Truffle. We basically are looking at two different environments for developing the Ethereum based smart contract. One is the remix based environment where we can write the backend code and we can test it using the various debugging options that are available in the Remix browser itself. So it has got your function debugger, it has got your virtual environment or the nodes that it automatically creates. Now all that is not there in Truffle. In Truffle, for testing the functions, you will need to write the test script. You cannot just run it the way we have seen in the Remix. So whenever I develop any smart contracts in Ethereum, I generally develop them in Remix and then test it thoroughly before I migrate it to the Truffle. And the reason is because it is very much easier to do in Remix rather than writing it in Truffle and then create a equivalent source code for testing it. Sometimes the test file is much more heavier than your original contract file. And apart from test file, you also have to write a migration file which migrates it to the environment. For example, if you are deploying it to the Ganache, we will need to write a deployment file which helps to deploy our contract to the Ganache. It's not like you just mention the RPC string and it gets deployed. You need to write a code here. Similarly, there are a lot of steps that you need to perform before your program can actually be made up and running in a Truffle-based environment. Only advantage is that you get one integrated environment available and ready for testing and deployment. So there is no possibility of integrating the UI or the third libraries or applications in Remix. You cannot just do that. You just have to assume that the events are getting emitted and they are being received by the applications. You cannot actually integrate and test it. So all that is possible in Truffle, while it is not possible in Remix. So that is the basic difference. While you create your initial contracts in Remix and test them there, then you migrate them to Truffle. And although it is written in the website that the Truffle also works quite well in Windows also, but there are stability issues when you install the node and npm on Windows and try to integrate them with Truffle. Generally gives lot of errors. So therefore it is much more stable in Linux than in Windows, and therefore we are doing it in Linux. First of all, as I mentioned, Truffle is slightly different from Remix. Remix gives you the complete end-to-end environment for writing your backend, testing it, and gives you the sample nodes as well. Truffle, on the other hand, does not give you any kind of a debugging environment, does not give you any kind of a dummy environment to test your smart contract, but it gives you the overall integrated approach of developing your web application, developing your Web3 libraries, and integrating all things together in a single piece of code. So that's the beauty of Truffle. What Truffle is basically is set of tools and libraries. So if you go to Truffle framework website, you will see that it's basically a suite of products, and it has got Truffle teams. Truffle Teams is a product where if multiple members are developing some kind of a smart contract or a Ethereum based product, then they can all collaborate through the Truffle Teams and develop a joint product. And then you have Ganache, you have Drizzle, you have many more products which are coming up for Truffle. The tutorials part, it tells you that how you can use Truffle not only for Ethereum, but you can also using for building your Quorum based apps for private enterprises. You can get the Ethereum overview, you can get the various constructs that are used in Truffle. How does it connect? It even has a connectivity with Hyperledger Fabric. So it's a very good set of tools that they have created for block. Primarily it is for Ethereum, but it has got connectivity with Quorum as well, and it can connect with Hyperledger Fabric as in some senses. So what we generally do is we use first of all Ganache tool from the Truffle framework, and then we also use the example or a template to develop our own smart contract. So for example, what we will be using now is a pet shop example. Okay, this is a ready-made piece of code which is available, and it tells you that how you write your smart contract from the beginning in a Truffle framework, and then how you write a test module, how you write a GUI module, how you integrate your GUI module with the test module or with the main backend module. How do you run GUI, and how basically the entire thing like Ganache, MetaMask, your backend all integrates together to run a pet shop. What pet shop is basically a online pet shop where you can purchase the pets, and once you do the purchase, it is booked for you and it is shown as booked in the UI. There are different pets which are available, and they have a price that you need to pay, and once you pay that price, own that pet. So this is a very simple and very basic example. Along with that, it also has a couple of more examples, like one of the example is there for coin, for creating a coin. Another example is there. So there are three examples which are there in Truffle framework, and using these as a basic framework, you can develop any kind of a contract. So for example, if you take the skeleton of a pet shop, you can easily replace your smart contract with any other contract, and you can replace your GUI with any other GUI, while most of the integrating functions will remain the same. And it will be much more easier for you to create your application rather than creating from a complete fresh skeleton application, because then you will need to write each and everything from scratch. We'll be using pet shop example in the Truffle framework to basically go through how we can develop our own application. What you need to do, it will tell you the step-by-step process of doing this. So first of all, you need to have Node.js version 8 or above. You need to have Git. You need to install npm install -g truffle. These are the things which are mandatory. Then you need to install Ganache, and you just need to press download button, and you also need to have the MetaMask installed. Then you can create a separate directory, pet shop tutorial. What I have done is I have created a directory called Edureka demo. Currently it is blank. Now I will need to use Truffle unbox pet demo. So what it will do is it will create the skeleton for the pet shop application in my folder. I will just run this command, Truffle unbox pet shop. It is downloading the skeleton. So the unboxing is complete and it has downloaded the files. Now it is showing the commands that you can use Truffle compile. So these are the commands that we generally use. Truffle compile is a command that we use to compile our Solidity file. Truffle migrate is the command which migrates your contract to the Ganache or any other Ethereum blockchain that you are using. Truffle test is the command that you use to execute the test script that you will create, and that test script will test all the functions in the smart contract. And then when you integrate the UI, the final command that you need to run is npm run dev. npm run dev will initiate your user interface on the port that you have given, and that UI can integrate with your smart contract. So these are the commands that you need to remember whenever you are using the Truffle. One thing you will notice is that the moment you did this unbox, you will see a directory structure getting created here. You see different folders like contracts, migrations. You also see folder like source, node modules, package.json, package log.json, truffle config.js. This is a ready-made environment that it has given. Now, in order to view these files, I generally use Visual Source Code Studio as an IDE. You can use any other IDE of your choice also, like Atom or any other IDE that you want to use. But I generally use Visual Source Code Studio because this is also the preferred IDE for Hyperledger Fabric. There are a lot of tools which are available for Hyperledger Fabric in this ID. So what you need to do is you need to say open folder, and you just need to mention this particular folder. I need to go to Anuj and Edureka demo. So I will just open this folder, say OK. So it has opened my entire environment. Here you will see different folders like contracts, migrations, test, and all of them are essentially blank as of now or with the minimum code. So this is the skeleton that it has created. Now let us see that what all is there in these folders. So if you go to this module, so there is a contract folder, there is a migration folder, there is a source folder, there is a test folder, there are some configuration files. This contract folder will contain all the contracts that you have created in a Solidity format, like the ones that we have been creating till now in Remix. Migration is a special folder which has a JavaScript file that helps you migrate your contracts to the Ethereum blockchain. Migration is a special smart contract used by Truffle to handle smart contract deployment. In order to deploy this contract to your Ethereum blockchain, you need to update your migration file as well, which is not the case in Remix because you simply just configure it with the RPC address. Now, this source folder generally contains your GUI files. So all your Angular, Java, all that kind of a source code is generally there in SRC folder. Generally, the file name is app.js, which contains your GUI. The test folder generally has your test files, and these are all your configuration files like package.json, truffle.js. They are all used extensively when you write your contracts. Now, currently, these are all either blanks or they have the minimal information. So we will need to write them one by one as it is mentioned in this tutorial. I'll go back to Linux. So we have done unboxing. We have already seen this directory structure. So there is a contract folder, there is a migration folder, there is a test folder. This is a Truffle configuration file, truffleconfig.js, and these are some of the extra files and folders which are there. So before we write this contract adoption.sol, because this is all about PAT adoption. So the contract name is adoption. What we will do is we will just try to use those commands which we saw earlier, like for example, truffle compile, truffle migrate, although they will not have much code to do, but let's see what happens. Now if I say truffle compile, it will compile my current code. Whatever is there, although it does not have the complete code, but whatever migration file is there, it will compile that and it will say compiling your contract. So currently we only have migrations.sol. We don't have the actual Solidity contract, so it has compiled it. Second command that we generally use is called migrate. It will migrate this contract to the blockchain. So this skeleton is already there. What I'm trying to say is this much is already there. So it will tell that, okay, this is the network name, this is the network ID. I have already deployed this. This is the amount of gas that I have spent it. This is already deployed, and this is deployed where? This is deployed on my Ganache, and you can see the blocks getting created here. This is the block of my contract getting deployed here. Although it does not have anything, but what I'm saying is that this is the bare minimum thing that you can run, and you can see all these here. And what you can also do is, because the GUI is already there in the source file, if you see this source folder, they have already created the GUI, although we have not integrated it with the smart contract, but they have created a GUI where they have created several pets which are ready for adoption. So if I want to run the GUI, what command I will use? I will use npm run dev, and it will open the pet shop GUI. So again, this is not connected with the backend as yet, so we will need to write that code. But what I'm showing is that how it will eventually look like. So it is compiling all the HTML, CSS, GUI files that we have written, and it will open it like this. So this is our pet shop where these pets are available for sale. UI is already created, but it will not work even if you press adopt or if you press anything, nothing will happen because there is no integration done with the backend. In fact, we have not written the contract as yet. What we need to do is we will just close it here and we will say Control C. So all this is closed. Now what we will need to do is We will need to follow the steps which are given in this, and we will need to create our Solidity contract in Visual Source Studio. So first of all, I will need to create a new file in the contract, which is called as adoption.so. This is the new file that I have created. Now, what will be the content of this new file? So what will be the content? So currently it is, initially they have kept it as blank. We have just defined the Pragma Solidity keyword. Then what they have done is they have defined this variable, and it is a public variable. Okay, they have defined an array. It's fine. I think we could have defined, it was better that we could have defined the mapping also. So this is the array and this is the function. So what it is doing is we are defining a Pragma Solidity construct. Then we have defined a contract called adoption, where we have defined 16 addresses, which means there can be 16 adoptions that can be done, and each pat is having a pat ID. So whenever we call adopt function, which is a public function that is part of this contract adoption, we pass a pat ID, which means that which pat we want to adopt. It will check if the pat ID is between 0 to 15. That means it is a valid pat. Then it will update the adopter's pat ID with the message.sender, which means the address will be updated here, that this pat belongs to this particular address. So this is a very simple contract which we are creating for pat adoption. What we are doing here is whenever adopt function is called, we are just updating the address of message.sender, which means the address which is adopting this pat to this array with the pet ID that is being passed. So for example, if the pet ID 5th is passed, then 5th value of the array will be updated with the message.sender address, which means the 5th pet has been adopted by this particular address. Or if you see in Ganache, so for example, if the third person is willing to buy the 5th pet, then the 5th adopter will be updated with the address of the third Ethereum address. So this is your basic adoption class that is written. We will just save the change. Now for every contract, we will need to write a migration file. Now what is the migration file and what is this migration.sol? This migration.sol is an initial contract or a basic contract with one setter function which is written here. And then we have the initial migration.js, which is a JavaScript file which just takes this migration.sol here and use a deploy function, which is a Solidity function, to deploy this migration. So the same deployment file we will also need to write for adoption.sol as well. So let's see how it works. So you have written this function where you have defined adoption.sol. What it is doing is it is taking a pet ID and it is updating the adopters array. Now there is one more function, because this is a setter function. Now we will also write a getter function where we are retrieving the adopters. So this is nothing but getting the values of this array. So for example, when you want to refresh the values in the UI, we will call get adopters function, which will return this entire array of adopters. This is the getter function, a view function, and this is a setter function. Now we can simply compile it, but we will not be able to migrate it because we have not written the migration file. But let's see what errors come. So if I go to my list, if I say Truffle compile, I am able to compile it. You see there are two files that are getting compiled. One is your adoption and another is your migration. And if I do migrate, then it will have error because I have not written the migration. So now what you will need to do is you will need to write the migration file. So this is your migration file that you will need to write, which is doing nothing but which is deploying this adoption contract to the. Okay, so I will create a file. What is the name? Underscore deploy contracts. Give any name. This is a JavaScript file. I will just write the migration code here. So now I have written the base SOL. I have also written the migration SOL. What is the next step that I need to do? I need to make sure that Ganache is running. So now when I will do Truffle migrate, it will show me that all these contracts are created. Now it is showing that this deploy.contracts that we just created is also migrated. And now we can also see that the blocks will get added here. There are 4 blocks that are getting created, and the ethers are getting deducted. This is working fine, which means that our Ganache is connected. So every time we are deploying, Now what we are doing is we are writing a test file. So in order to run truffle.test, we also need to have a test file. So the test file can be written in JavaScript. It can also be written in Solidity. So since we are studying Solidity, so therefore we are writing the test file in Solidity. What we are doing in the test file is we are simply creating these contracts that we have created in adoption.sol, and we are seeing the expected output. So that's all we are doing. So we need to create one file, test adoption.sol, under the test directory. So this is my test directory. Where is my test directory? So this is my test directory. I will create a new file, test adoption.sol, and what I'm going to write here is, again, you can also write it in JavaScript. There is no need that you need to write this test file in Solidity only. You can write it in JavaScript also. Now what this test file is doing is it is importing all these assert.sol is a by default assert file that Truffle has, then this deployed address.sol, and then the adoption.sol that we have created. We are creating new contract copy with this adoption address, and we are checking whether the getter function is returning the expected value or not. The expected owner is getting returned by this particular test file or not. So we can just compile and try to run the truffle test as well. Let's compile this, and then we can use truffle test to run this test script. This is the only mechanism which is available to basically debug your functions, Truffle. You cannot debug them like the way we were doing it in Remix. So you will need to write test scripts. You will need to write all test cases that you can expect. Now these assert.sol and deployed address.sol, these are all part of your Truffle framework. So they help you with certain functions. So now you need to write these functions in the test script file. So initially we defined it. Now let's test the adopt function, whether it is functioning correctly or not. So we'll go to test adoption.sol. We'll write this first function. This is just like writing your functions in a normal contract file. But what you will notice is generally the test files are bigger than your normal contract because you need to test all the scenarios. Here what you are testing is whether the adoption function is working fine or not. So you're calling this adopt function with the expected pet ID, and you are checking it with the assert whether it is returning the correct pet ID or not. Similarly, you can check other functions as well. Now this is another function where you are checking the retrieval of owner is correct or not. If you have a pet ID, then you should have a corresponding pet owner. So it is the function which is checking that the owner is correct or not. Then you can also write function of getting all the owners. Like we implemented a getter function. Here we are calling get adopters, which is the getter function that we wrote, and we are implementing this third function. All these functions will be automatically called, and the results will be displayed whether they have passed or not using the assert statements. So these are the three functions that we have written, and every one is basically terminated with assert function, which will check whether it is returning the correct output or not. When we execute this test script now, it will check all these three functions. So let us see if there are more functions. These are the three functions that we need to test. So now we will run truffle test again. It will recompile this option file and it will run all these three functions automatically. So it is taking the instance of the adoption.sol class. It is running all three functions one by one. To test adoption, it is running this function now. So it has passed all the three functions. Test user can adopt pet, test get adopter address by pet ID, test get adopter address by pet ID in array. All three functions where we have tested whether the user can adopt the pet or not, whether the address is a valid address or not, and whether it is returning the entire array or not. All three functions are working correctly. That's how you write your test. Now there are some files that you should be aware of. Like one of them is truffleconfig.js. In truffleconfig.js, basically you need to give the port and the IP address of the chain network that we are going to use. So in our case, what we are using is we are using Ganache, which is exposing a port number 7545. And because it is running on my local machine, therefore, I have given the host address as 127.0.0.1, which is a loopback address to my own machine. And 7545 is the RPC port on which this Ganache is running. So in case you are using some other blockchain network, for example, you create your own blockchain network, so you will need to modify the port accordingly so that you can connect with that particular chain. So this is something that you need to keep in mind while you are writing your smart contract. So this package.json will come bundled with this like Truffle unbox pet shop. This will come bundled with this. Otherwise, if you don't want to use any existing template, or if you don't want existing GUI to be integrated, what you can also do is you can write the command truffle space init, basically create a skeleton program. Let's say example that it is showing that the test is run successfully. Let's say I create one example, one directory temp. Instead of unboxing pet shop or any meta coin, or the examples which are there in Truffle framework, if I want to create a pure skeleton that does not have any pre-existing code, I can also do Truffle init. So Truffle init will simply create a package where everything will be empty. So I will have a contract folder where there will be no contract. I will have a migration folder. I will have a test folder, and I will have a default truffle config.js. If you see this file, it will have the option of connecting with various kind of hosts. So, various kind of blockchains which are available. So you can uncomment any of these, or you can write your own as well. So everything currently here is commented. Another way of creating your skeleton. Now let's go back to this program. Now, apart from truffle config.js, we also have packet.json. This is another configuration file where you mention the details of your program, such as the name, version, what is the configuration file, is the main directory that you're going to use, what is the test directory that you're going to use. All these information, like the author, license information, dev dependencies, etc., you can mention in this in a particular format. So this is all in JSON format, basically expect you to give. Package.json and truffleconfig.js, these are the configuration files that you need to give. Apart from that, this particular source folder is where your UI is placed, or where your Web3 APIs are there that gets integrated with your smart contract. If you open this source folder, you will find, like, for example, index.html. This is the basically the source code of your front page, like all those images of various dogs which are appearing, and the buttons that are appearing, they are appearing from this particular page. So I'm not going into the detail of how you create HTML or how you create the front end. I think you can have a look yourself. What is important to cover here is this file app.js. Go to app.js. This app.js will basically give you the complete skeleton of writing your Web3 APIs. So it will give you functions like the initial constructor function, this particular constructor function, init function, which automatically runs, will call this API app.init Web3. Init Web3 will basically initiate the Web3 APIs. So we will need to write the source code of init Web3. Init Web3 will call init contract, which will connect the smart contract with the Web3 APIs. And then init contract will internally call these functions like mark adopted, handle adopt. Mark adopted means whenever you select a pet to be adopted, then mark adopted function is called, and it calls the smart contract functions, whatever we have written to adopt a pet. And handle adopt basically refreshes your entire data set. The skeleton is already written. Now we will need to write the source code of these functions, and these are all part of your Web3 API interfaces that are available. Now you can also write the way you like them. Basically, this is the function that will always be executed in the beginning. Whatever you want to write here, you can write. So let's see that what code we need to implement here. Let's go back to the pet shop example. Now what we are going to do is we are going to execute this function. The first function that will be called from init is your init web3. Init web3 is going to initialize the client that is connected with your system. So for example, we are going to connect MetaMask as our DApp browser, or the basically the wallet application that is going to get connected. So this particular command, if MetaMask is up and running, then this will be run as true, and Web3 provider will be initialized with windows.ethereum, which is our MetaMask, and then towards the end, Web3 will be initialized with this particular Web3 provider. Otherwise, if there is no MetaMask or there is no Mist browser, then it will be directly initialized with the Ganache. Then Web3.web provider will be directly 7545 localhost, which is our Ganache client. So right now what we are doing is, in case our MetaMask wallet is available, then we are connecting it with the MetaMask. Otherwise, we are connecting it with the Ganache. So this is the source code which we will need to copy in init web3 function. So let's go to init web3. I have just copied this source code. Now after running this source code, what it will do is it will initialize web3 with my web3 provider, which is MetaMask in this particular case, and then it will call init contract. Init contract is the next function that we are going to implement. So let's see what we need to write in init contract. Ethereum.enable is basically requesting the accounts that are there in the MetaMask to be imported to this application so that we can use them. So this is the injected Web3 instance that we are going to use. Now for initiating the contract, we are running this particular code. This we need to write in init contract. What it is doing is it is basically taking the instance of our adoption contract and it is creating a new instance, and the provider we are setting at web3 provider, which we have already initialized in the first function. So we are taking the instance of our contract class or adoption contract class and we are initializing it with the web3 provider that we have basically fetched in the first function. So let's copy this particular code. Where do I need to copy this? To copy it here. And after setting the provider with my Truffle contract, what I will do is I will call the mark adopted function so that all the entries which are currently marked in my MetaMask as already adopted will be refreshed in my contract. Currently, because we are running it for the first time, so therefore no entry will be marked as adopted. So therefore, this will just run without any result. But in case you have already adopted some patch earlier and then you are connecting again with these Web3 APIs, then your GUI should show the earlier entries as adopted or already sold. Therefore, this function will not only initialize your contract, but it will also check that what all entries are marked as adopted, and it will mark those entries as adopted in the GUI. Now, mark adopted function, since we have called from here, let's see what is the source code of particular function. So we then call apps mark adopted function in case there are any pets that are already adopted from the previous visit. We have encapsulated this in a separate function since we will need to update the UI every time we make a change to the smart contract data. So mark adopted function, what it is doing is it is just taking the instance of the class. It is running the loop. It is checking that which address is marked as adopted, and it is making changes in the GUI. So it is running a loop. It is checking that what address is marked as adopted, and then it is making the changes in the UI in the panel pat. These are all UI components, HTML components. It is checking whether the button is successful or disabled, and accordingly it will change it. So once you adopt a pat, the button will be disabled. So those changes are done in this particular function, mark adopted. So just copy it here. So I have copied this function, and then I think the last function that we will need to implement is handle adopt. Handle adopt is the function which will be called when we initiate any adoption from the GUI. Mark adopted is already done. Now we will do handle adopt, which is similar to mark adopt only, but it will also call the contract function. So this is the source code of handle adopt. Now we use Web3 to get the user's account. In the callback after the error check, we then select the first account. So we check that which account is basically adopting, whether that account has already adopted or not. If it has already adopted, we will return an error. If it has not adopted, then we will check the balance and the gas that is available or not. If it is not available, again it will return an error. And in case everything is successful, then we will call the adopt function of our main contract, where the transaction will execute and the pet will be marked as adopted. So we will again call this function mark adopted in case it is successful. If the result is successful of this adoption, then we will again call the mark adopted. This mark adopted is a function which will make the changes in the UI. It will again mark that button as disabled so that it is reflected that the PAT is already adopted. So let's copy this code as well and we'll adopt. I think that will basically complete our Web3 code that we are doing. Now the next step, what we are going to do is, I will see that my Ganache is up and running. It has created so many blocks because we have run test and everything multiple times. I will see that my MetaMask is running. My MetaMask should be connected with Ganache, and I should be actually importing some accounts that those accounts can be used for adoption. So I have basically imported this account number 234. I have already imported. You can import more accounts by using the private key. We have already seen that. For example, the first three accounts are already included. If I want to include this account, what I will do is I will copy the private key and I will say import account. I will give the private key here, import, and this account will also be imported. Similarly, I can import all the accounts. Currently, I have only imported 4 accounts. Now, what I will do is I will again need to compile this program. So I will say compile, then Truffle migrate. Now let me run the test again just to make sure that everything is fine. I have not booked up the source code. So all 3 test cases are passed. Now in order to run the GUI, what I will run is npm. These are the steps that it has given for installing the MetaMask and setting up the MetaMask. npm run dev. This is the command that you need to give for npm run dev. So this is the command that you will need to give start your GUI, which is running on a local host number 3030. Now I think we saw this GUI, but the difference now we have a source code which is connected with a backend application or a smart contract or Ethereum based smart contract. This is basically a decentralized application where you can run it from any node which is an authorized user of this network. In our case, all the nodes which are part of our Ganache network are all the authorized nodes basically adopt the pack. So now, for example, if currently my first address is selected, now let's say I want to adopt French Bulldog and I click on adopt, it will open my MetaMask. If you remember, the first thing that happens is it connects with your Web3 Windows wallet application, which is the MetaMask in our case. It is saying that, we are using account to basically adopt a pack. And, this is the fees, this is the amount of gas that will be incurred. We have not associated any kind of a currency or a payable function. So the price is 0. So, adoption basically means that, you're not paying any price, but you are just adopting it. But also what you can do is, I think you can make the adoption function as stable, where, you can give some kind of a mandatory ether value for adoption. So that also you can do, but it's not there currently. So if you say confirm, transaction is successful, you can see that this pat is adopted. The adopt, this thing is changed to success. We already saw this in Web3. When you call this mark adopted function, you are changing the button from success and you are making it disabled. That's what exactly has happened. This pat is marked as adopted by account number 2, and you can see these transactions here also. This block is created. These are the transactions that have happened. This is my contract account, this is my sender address, the value was 0 ether, and this is my transaction data. My transaction data will have the details of the pet and which account has adopted it. And similarly, you can see the block details. It has got one transaction. This is the transaction. Similarly, you can mark other pets for adoption. Now another account, say account number 3, and I want to adopt some other dog. Let's say this one, Boxer. Again, it is showing me that account 3 is trying to run this transaction. If I say confirm, it should run successfully and the dog will be marked as adopted. This is also marked as adopted, success. Okay, you cannot adopt it anymore because this has already been adopted. Transactions will be added, block is created, and this is the transaction detail. Basically that completes your end-to-end cycle of application development in Ethereum. So using the Web3 APIs, integrating it with the UI, the Truffle framework, each and everything that you need to develop or write your own application. You can use Ganache, you can use your own private Ethereum network, you can use MetaMask or any other wallet application. So it's all readily available for you, and now you can go ahead and develop your application. It is taking another example of EduCoin, education-based coin. So, we have taken the example of pet shop. So this is a simple contract, basically creating a simple currency for a online education. We already know these deploy JavaScript functions. We already saw Truffle.js. We saw package.json. npm install we need not do. Truffle compile, Truffle migrate, npm run dev. How does it connect with your MetaMask? How does it connect with your Ganache? What is the outcome step by step? Most of the things, this module. So that basically finishes your Ethereum. Thank you.